Hi guys, welcome back. So today we're doing a problem on projectile motion, and if you guys still don't know what's a projectile motion, I've made a video on that. I'm gonna provide the link in the description below so you guys can check that out. Okay, let's get back to this problem. So here it says a shell is fired from ground level with an initial speed of 480 feet per second at an angle of elevation of 30 degrees. Okay, so let's just draw this. Okay, let's just say this is a shell. Now we're launching it at an angle or with a speed of 480 feet per second, okay, and at an angle of 30 degrees. And you know the projectile motion is like a downward facing parabola, so this is how the trajectory is going to look like. Okay, and you know that there are two components in the projectile motion, the horizontal and the vertical component. So let's just break this down into x and y component. Okay, and what are we finding? Find a vector function and the parametric equation of a shell's trajectory. Okay, so the vector function, since this is in the projectile motion we have a horizontal component and a vertical component. We have a horizontal component and a vertical component, so we're going to be writing the equation in the x of t in the x form and the y form. So in the x component and the y component. Okay, so this is going to look like x of t I hat plus y of t g hat. So this is the vector function that it's gonna look like. We're gonna calculate it in a second, so don't worry, I'm just explaining what is it. And then the parametric equations are simply just like the equations of the vector function. So this is the vector function, and parametric equations are just x of t equals to and y of t equals to. Okay, so this is our goal to get. Our goal is to get to this. Okay, so now let's get started. So to find x of t, the formula is vx t, and to find y of t, the formula is vy of t plus s0, which is the initial height that the shell was thrown at. When here it was thrown from the ground level, so this will be 0 in here. Okay, and then negative gt squared divided by 2. So this is the formula that we're using. And what is v of x and v of y? So you know, in projectile motion the initial speed given to us is 480 feet per second, and to find v of x, the velocity in the x direction here, so the velocity in the x direction, and there is a velocity in the y direction. So to find the velocity in the x direction, what do? We do 480 cos of the angle, and here the angle is 30 degrees, so 480 cos 30, and then to find in the y direction we do 480 sine 30. Okay, now if you calculate that, this should give you 240 square root of 3t, and this should give you just 240. Oh, not t. Okay, so now when we have the initial speed in both direction, in the x and y direction, let's plug into these formulas. So the parametric equation in the x direction would be just x of t, vxt, we know vxt is 240 square root of 3t. So this is our first parametric equation, and the second one, and don't worry, you can write this in decimal if you want. Okay, and vy is 240, so 240t plus s0, like I explained before, it was thrown from the ground level. Here you see ground level, so which means there was no initial displacement here, no height at the beginning, so that's why it's just 0. Okay, let's scroll down. Why it's not scrolling down? Oh, I was here, sorry. Okay, so this is 0 then, so 0, and and negative g. Okay, g here. What is g? G is 9.8 meters per second square, right? But did you notice here the units are not meters per second? It is in feet per second. So we're gonna have to use feet per second squared in for the g as well. So let me give you the conversion here. You guys can note this somewhere in your notebook so that you remember, because it's really important for the exams. They can give you any measurement and you have to know this. So 9.8 meters per second squared is same as 32.2 feet per second squared, and it's the same as 9.8 Newton per kg, and it's the same as 386.4 inches. Okay, so these conversions, you have to know these conversions. Okay, I can just write this in the description, okay, if this looks so messy in here. Okay, so what is it? So it is 32.2. okay, so we're using 32.2 feet per second squared for the g here. Okay, so 32.2 divided by 2 and t squared, and if you simplify this, this should give you 240 t minus 16t squared, and this is for the y of t. Okay, so let me write this neatly at the bottom. Okay, so the parametric equation is just this: 240 square root of 3t, and y of t is equals to 240t minus 16t squared. So this is the parametric equation. And if you want to find the vector equation, how do? You just combine them in the I hat and the j hat. So the vector equation is equals to the vector function. It's going to be x of t I hat plus y of t j hat. So you have x of t and y of t, just have to write that in here. So this is going to be 240 square root of 3t I hat plus 240t minus 16t squared, and then g hat. Okay, so this is the vector function. So this is the vector function that is given to you. Okay, that you were supposed to calculate. Okay, so this is the answer for part A. Okay, now let's move on to part B. So what is part B? Part B is to find the maximum altitude attained. So which means we have to find the maximum height that the shell reached. Okay, so this is the maximum height that we're looking for. And how do we calculate this? Do you guys have know any hint to calculate this? Just think about it. Do you guys know anything that is related to maximum height? Just think of it for a second. You don't know it, right? Okay, so this is the velocity. Remember, the velocity at the very top is equals to 0, right? So we can use this to solve the maximum height. Okay, let's do this at the bottom. Okay, let's just do it over here. Okay, B. So we're finding the maximum height. Okay, and for that we know the vector function. We know the velocity is equals to 0, and the velocity in the y direction, right? Because in the if you have watched my previous video, you know that the velocity in the horizontal direction, it remains constant, so it doesn't change. Only in the velocity in the y direction, it's going to keep changing with time. Okay, so and at the very top it's equals to 0. So the y of t, we are going to use this equation because we're talking about the velocity. The velocity is changing only in the y direction. Okay, so y of t was equals to 240 t minus 16 t squared, like we wrote it at the top, this equation. So we're going to use this equation to solve it. So this is the equation, right? And this is the position equation of the y. If you want to find the velocity, do you remember how to calculate velocity from position? Right? We take the derivative of it. Okay, so let's just take the derivative of it to find the velocity. So if we take the derivative of it, it gets 240 minus and 32t. Okay, now we need to make it equal to 0. So now let's make this velocity equals to 0. Okay, now we calculate for the time. So if you do this correctly, okay, now just 240 divided by 32t. So then the t is equals to 7.5. Okay, I guess it looks like 75. Let me just rewrite it. 7.5. Okay, so 7.5 seconds. So the maximum height was reached at the 7.5 seconds. But our question was not to find the time of the maximum height. Our question was to find the height of the maximum height. So now when we know the time that the maximum height was reached, can we find the height? How? We know the position equation, right? We know the position equation, so this can help us to find the height. Okay, so if we plug in 7.5 here, so we will know what was the height at 7.5 seconds. So that would be the maximum height. Okay, so now let's calculate this. So in the y of t equation, we are plugging in the time 7.5. Okay, and then if you do this correctly, this should give you 900 feet, because remember the units are in feet per second, so 900 feet. Okay, so the maximum height is 900, and this is it for part B. Now let's move on to part C. So the part C says the range of the shell. What does that mean, the range of the shell? Okay, let me explain you what is the range of the shell. Okay, so you know, when it was launched, so the distance that it traveled from its starting point to the end point, this is the range. So we're looking for this. So the total horizontal distance that the object has covered. So this is what we're looking for. Okay, so how can we calculate this? Okay, so we know that the object hit the ground in here, right? We have to find the x displacement when the object hit the ground. So we know the equation of the y of t, right? So y of t, we can make it equal to 0, right? Because it hit the ground, so we know the position is equal to 0, and then we can calculate the time when it hit the ground. Okay, so when we have the time of the hitting the ground, then we can plug in that time, the time that we get, the t value, we can plug it into the x of t, and then this is how we're gonna find the total distance that it has traveled horizontally. Okay, let's get back to work now. Okay, so what are we doing first? We're calculating for t when it's the vertical displacement is equals to 0. Okay, so let me write the equation of it first. So which was 240 t minus 16 t squared is equals to 0. This is what we are making it equals to 0. Remember, y of t is equals to 240 t minus 16 t squared. Okay, making it to 0. This gives us, okay, for that we'll have to factor it first. Okay, so if you factor 16t, you're left with 15 minus t is equals to 0. Now you can just split it out. So 16t equals to 0, and then this equals to 0. So then 15 minus t is equals to 0. So if you do this, this should give you t equals to 0, and then here it gives you 15 equals to t. So at 15 seconds and at t equals to 0 seconds, at the 0 second and at the 15 seconds, the displacement was 0. So the position was 0, right? At t equals to 0, it makes sense because we launched it from the ground, and that's why the position is 0. And when it traveled all this distance, so it traveled it in 15 seconds and then it hit the ground. So this is what we needed. So we'll just discard this. We're looking for this only. So 15 seconds. Now we will just plug this into the x equation. Okay, so x of t is equals to, so let's check what is x of t, which is 240 square root of 3t. So 240 square root of 3t, and now plugging it in 15 in this equation. So 240 square root of 315, which gives the displacement of 6235.4 feet. Okay, so this is the range. So just calculate it for part C. And by the way, this is 15 seconds because when you calculate it, remember in part B, okay, so here in part B, when we were calculating for the maximum height, we got that from here to the middle of it until it reached the height, the maximum height, which is the middle, right? So the time was 7.5, and if you want to know the time of the total trajectory when it hit the ground, it would be twice of this, because this is half, and if you do the other half, which is 15, so you can simply do 7.5 times 2, which gives 15 seconds as well if you want. So this is an easier way. If we neglect a resistance, so it would be just twice the time of the maximum height. Okay, so let's move on to part D now. Okay, so part D is the speed at impact. So the speed at impact, what is the speed at impact? Okay, I guess this video is getting so long, so let me just do the part D in the next part. Okay, so until then, bye.